AP Cram, Calculus AB, Free Response, Exam Review, Question 29, Integral Expressions for Equal Areas. Let R be the region enclosed by the graph. F of x is equivalent to x to the fourth minus 2.3 times x to the third plus 4. And the horizontal line y is equivalent to 4, as shown here in the figure. The vertical line x is equivalent to k divides the region R into two equal areas. Write but do not solve an equation involving integral expressions whose solutions give the value of k. All right, so I'll give you a moment to think about your strategy. All right, so in order to solve this problem, the first thing that you have to establish are the bounds of integration. So we're told that we're integrating region R. So the bounds of integration in relation to the x-axis are going to be from 0 to some number here, and between the line y is equivalent to x and the function that we're given f of x, okay? So in order to solve for the exact bounds of integration, what I did in flashcard set 27, you can just go back and watch that, is set for y equals 4 equivalent to f of x, so we can find out the points of intersection or the limits of integration. And then we know our upper bound and our lower bound in terms of the functions that are cutting off for region R, okay? So basically, we're told that we have some imaginary line k. So let's just draw in k for good measure. Let's say k is right here. All right, so this line k, although this is not drawn to scale, it's going to split region R into two equivalent regions. So this region is kind of sort of equivalent to this region, although it doesn't look like it. Just pretend, okay? So we have to set up integrals such that the area to the right of k is equivalent to the area to the left of k. So let's first establish the region to the left of x equal k. All right, so that's going to be the integral from 0 to k. So from 0 to k, because 0 is our lower bound of integration that I show you how to arrive at in flashcard set 27 of this series. And then the equations that go in the integrand are from 4 minus f of x, and this is f of x right here, dx, because we're integrating with respect to the x-axis, okay? So this is the equation for the region to the left of k. Now, the equation for the region to the right of k is very similar. So we're going to analyze this region. So it's going to be the integral, the lower bound is k, up to 2.3. If you watch flashcards at 27, we solve for x, and x is either equivalent to 0 or 2.3. These are our points of intersection of these two functions. And so the integrand that's being analyzed in the integral is going to be 4 minus f of x, and we're integrating with respect to x, so dx, okay? And now, in order to ensure that these two regions are maybe not visually, but are mathematically quantitatively equivalent to each other, you have to just set these two equations equivalent to each other, okay? So the final answer is going to be the integral from k to 0 of 4 minus f of x dx is equivalent to the integral from 2.3 to k of 4 minus f of x dx. All right? Okay. Just, even if you're a little uncomfortable with this, just take your time with it. And when you encounter more problems like this, you'll